All right, so today we are rounding off our final exam review. So what we're doing in these PowerPoint slides and the questions we're working is we're really just kind of touching on all of the concepts. You could view it like skimming the surface, right? Okay, so here's in a nutshell all of the types of questions that you're going to see on your final. Obviously today is Monday, so what we're going to be doing for the rest of the week is then we're going to be bringing it together even more, doing more practice over the types of problems that you're going to see on your final exam. Tomorrow you also have the notebook check like we just talked about too. All right, so first of all, let's talk about relations and functions. So a relation is any grouping of ordered pairs. All right, so it doesn't matter what the x values are, what the y values are. A relation is just a grouping of ordered pairs. So you see here, how many ordered pairs do you see?
1, 2, 3, 5.
5 ordered pairs. It's a relation. Any grouping of ordered pairs is a relation. Now, in order for it to be a function, it has to meet certain criteria. And here's the rule. Each input can only have one output value to match it. All right, so the first thing I'm going to do is I'm going to go across and look at my input values. So I want you guys to go ahead and copy down these 5 ordered pairs. These 5 ordered pairs. And then when you're copying them down, I want you to underline the input value in each ordered pair. So I will remind you that the input value is your x value in the ordered pair. All right, so go ahead and write down all 5 of them and underline the input values. Okay, which numbers did you underline? 1, 2, 3, 2, and 6. So when I'm looking at my input values, I'm looking to see if any of them repeat. Does any input value repeat? Yes. So if it does repeat, so I want you now to circle the 2 ordered pairs that repeat. This would be good work for you to show on your final exam too if you have a question like this. So circle them so you can really focus on them. If the input value repeats, it must have the same exact output value on both. Meaning, if I have 2 ordered pairs that are both the exact same, that's still okay. It's still a function. Right, Thomas? Okay. Do I have the exact same ordered pairs though? No. So this is not a function. I say no because the input 2 has 2 outputs. Okay, so the relation is not a function because the input 2 has 2 outputs. Yep, no. And then there will be like a remember this is multiple choice, so I'll have some different reasons. So if I said no because the output has 2 inputs, that's not correct. I'm looking at input values having only 1 output. All right, so now let's jump into exponents. So this is definitely the slide that you have a decent number of questions on your final exam from your exponents unit. All right, exponents, I will say this is the part where in second hour I reminded everyone kind of like the structure of your final. How many questions did I say was going to be on your final? 50. There are 50 questions on your final, which means that you can miss 15 of them and still get a 70. Anything below a 70, in my opinion, is not passing, okay? So that means you have to get 35 questions right on your final exam. These are the types of questions that need to be part of that 35. You can't miss these. These are not the hardest questions on your exam. You have other questions that need to be your quote-unquote cushion questions, all right? Part of that, hopefully you don't miss 15, but if this is part of the ones that you're missing, we're kind of raising some red flags here. Does that make sense? So simplifying these exponent expressions has to do with you remembering your exponent rules. We're just going to pause here for about a minute and let you guys work through these 5 problems. Okay, m to the 4th times n to the 9th. What did you guys get? M to the 13th. What property is this called where I would add the exponents when I'm multiplying? Does anybody remember the name? Product of powers. So watch this. If I were to give you a question on your final and I said, which one of these expressions is an example of product of powers? Could you point out one that looked like that?
No.
Okay, so it's not just about evaluating. You have to remember what the properties are called. All right, what about the next one? What did you guys get? G to the 32nd power. What property is that called? Power of powers. So again, if I were to ask you a question, which one of these expressions is an example of power of powers? Hopefully you could pick out one that looked like that. One base raised to a power raised to another power. All right, what about your H's? What would that reduce to? H to the 3rd. What is that property called? Quotient of powers, not division of powers. Quotient of powers. All right, so maybe some of those, it's not subtraction of powers, even though I'm subtracting my exponents. It's called quotient of powers. All right, someone raise your hand and tell me, what do I need to do to that negative exponent to make it positive so I can solve it? Jada, what do you think? Very good. So this is not 4 times 4 is 16. This means 4 times 4 times 4 times 4, okay, which is 256. So on this last problem, if I were to give you these 3 answer choices, which answer choice, all right, so this is going to be A, B, and C. Which one is the correct answer? It is A. So remember, taking a multiple choice test for math is very different. You also have to be confident enough that when you see the none of the above, because you're going to see this option on almost every single question on your test. Let's say these were your answer choices, 27 and B, 9B to the 3rd, 3B to the 3rd. Then your answer would be none of them, because you would be confident enough to know none of those was the correct answer. All right? So just because it's multiple choice doesn't mean it's going to be an easy test. You have to be confident in your answers. You guys tracking with me? Following along? I'm not losing you yet, right? Okay, it's a pretty short lesson today. Scientific notation. So I need you to write these 2 numbers in scientific notation. Remember, that decimal value has to be greater than 1, less than 10, and you multiply it by 10 to a power, 10 to some exponent value. Go ahead and try to work these 3 problems, all 3 of them. Again, we're just going to take a couple minutes, pause here, let you guys work them out, then we'll go over the answers. Where do I shift my decimal in the number? Matthew, where'd you shift it? To the right? Where? Between the 6 and the 2. You should have 6.24. This decimal value can never be negative because it has to be greater than 1. Is 6.24 greater than 1? Is it less than 10? Yes. Now, each place value is a power of 10, whether it's decimal places or whole number places. So how many place values did I shift the decimal by? I hope you're paying attention. How many, guys? 6. Now, it's negative. The exponent is negative because this was a very, very small number. So making it negative tells my reader, if they're trying to write this in standard form, that this is a very tiny number. All right, Hope, what is the decimal value going to be on the next one? What'd you say? 1.468 times 10 to the 8th power. Okay, so 10 to the 8th power. This definitely will be an answer option on your test. The exponent, however, is just slightly off. Do we count the zeros or do we count the place values? Place values, okay? So there are 8 zeros here. However, my decimal is not after the 8. Where is my decimal? It's after the 1. So you have to count all the place values. How many is that? 11. 10 to the 11th power. All right, so make sure you count place values. Okay? All right, what am I doing in this next expression? Am I adding, subtracting, multiplying? What am I doing? What am I doing, guys? On evaluate. What sign is in between the expressions? Addition. So my rule when I'm adding in scientific notation, we're going to be doing a lot more of these. This is on your final exam. If I'm adding, what do I have to look for? Common what? Common powers. Common powers of 10. Just like when I'm adding fractions, I have to have a common denominator. When I'm adding in scientific notation, I must have a common power. Do I have a common power here? Yes. So my rule says to bring down the common power into my answer. Just like you would bring your common denominator down. Okay? Now, because I had the common power, I can add my decimal values together. What is 9.2 plus 1.4? 10.6. This will definitely be an answer choice on your final, but it is not right. Why is this number not in scientific notation? It's bigger than 10. So what is my rule? If I need to bump my decimal to the left, what happens to my power? I increase it. Okay, so to get to that common power, to move my decimal left, which is what I need to do to make 1.06, I must add 1 to my exponent. This is the correct answer. So you can definitely expect that first option to be one of your answer options as well, but that's not the correct answer. You have to make sure it's in scientific notation. Any questions? Any questions? All right, we're going to shift gears to rational numbers. You will be excited to know that I have not included a repeating decimal on this final exam. It was on the final exam last year. It will not be this year. It's a little bit of a different emphasis this year on your perfect squares and your perfect cubes, which you will have to know. Okay. The square root of 144 over 225 in pre-algebra, fortunately, you're taking the square root of perfect squares. So you just have to have your perfect squares memorized. What is the square root of 144? 12. What is the square root of 225? Okay. Is this fully reduced? No. What do I reduce it to? Paying attention back there? What do I reduce it to? 4 over 5. All right, go ahead and do the next one. The cubed root of 216 over 512. Cubed root, not square. All right, what is the cubed root of 216? 6 over 8. Can I reduce this at all? Yeah. 3 over 4. So 6 over 8 is not the answer. So if I were to put that as one of your answer options, you're not going to pick it. 3 over 4 is the right answer. All right. Approximating. These numbers, pay attention. These numbers are not perfect squares and they are not perfect cubes. But maybe they are close to a perfect square or a perfect cube. You're going to need to know which one it's closest to so you can take the square root or the cube root of that number. All right, so let's go ahead. I'm going to give you some options because, again, these numbers are going to be multiple choice on your exam. So the cube root of 353, is that closest to 6, 7, 8, or 9? Write it down on your desk. Write it down on your desk. Square root of 50, is that closest to 5, 6, 8, 4, or none of the above? What is the closest perfect cube to 350?
7, 8.
Okay, the perfect cube of 7 is 343. So it's only 7 away from that. So 7 is the closest integer. All right, what about the square root of 50? Which choice? It's 7. It's 7. The square root of 49, that's only 1 away. The nearest integer is none.
I mean, you could have put that like.
I forgot that was a choice.
Oh, none was right there. Okay. There's only 4 possible choices on your final. I give you 5 choices. Okay, the correct answer is none. I think after this it was just inequalities, and I want to revisit the inequalities. You won't have to do the compound. I want you to solve this inequality, and then I want you to write an inequality statement. All right, and I think that this is the last 2 problems for today. All right, on the inequality, did you divide both sides by -3?
Yeah.
Did you remember to flip your sign?
Yeah.
All right, so definitely another option would be greater than, but you're not going to pick that one. Open or close dot on -10.
Open.
Open, and which way does your arrow go? To the left. All right, a baby tiger weighs at least 12 pounds at birth. So all of the, we can do P for pounds, all of the acceptable weights, if they have to be at least 12 pounds, would they be greater than 12 pounds, less than, would they be equal to? What do you guys think? Greater than or equal to. So if it's 15 pounds, that's a true statement. Weighs at least 12 pounds at birth. All right, Mr. Baby Tiger. Okay, so we already did volume, so that's going to cover it for today, for this part 3.